Welcome to a new lesson. In this lesson, we'll learn why there is a need of a new MapReduce framework and how the job is carried out in YARN. YARN is an abbreviation for yet another resource negotiator. It is also known as MapReduce 2 or the next generation MapReduce. While using MapReduce 1, it was observed that the scalability got saturated when the cluster size increased to 4000 plus nodes, majorly because of the load on the job tracker. In 2010, Yahoo started the project to create the next generation MapReduce with more features to increase performance by smarter memory utilization and enhance scalability and flexibility so it could accommodate and run many versions of distributed framework in parallel on the same cluster. Of all the changes, the main idea was to split the job tracker's responsibility in two portions. So job tracker got split into two. First, resource manager, which dealt with job scheduling portion of the workload. And second, application master, which dealt with the task monitoring portion of the workload. Programs written in MapReduce 1 or older APIs still work well on YARN. With the introduction of YARN, only the framework, that is the way of execution of MapReduce programs, changed. And so YARN supported both the programs written in the older APIs and the newer APIs. On this slide, we'll look at the advantages YARN brings over classic MapReduce. First and foremost is that the scalability increased dramatically with splitting the responsibilities of job trackers into two. Second, more than one YARN could coexist on the same cluster. Along with MapReduce, there can be another distributed framework alongside it on the same cluster. Third is the better utilization of memory with the introduction of the containers concept. Containers conceptually are similar to the slots in classic MapReduce. Just that in classic MapReduce, the slots are fixed in nature, while containers are more flexible. In classic MapReduce, a single task tracker would have fixed number of slots specific for map tasks and reduce tasks. However, the containers in YARN can run map, reduce, or any other task and are flexible. This results in better memory utilization. Next, we look at the entities in YARN. First is the client, which is the same as we saw in classic MapReduce. It is responsible to submit the job and interact with MapReduce and HDFS framework. Second is the resource manager, which is responsible for allocating the computing resources that are required by the job. Even in the resource manager, the job responsibilities can be classified into two. One is the scheduler, which only deals with scheduling of job and it doesn't perform any monitoring or tracking of application status. And another portion is the application manager, which monitors the application statuses. Third is the node manager. This is present on all the slave nodes and is responsible to launch and manage containers. Fourth is the application master. Please note that earlier I mentioned two portions of resource manager as scheduler and application manager. And application master is a completely different entity. Application master is responsible to carry out execution of the job it is associated with. It is the one which coordinates the task running and monitors the progress and aggregates it and sends reports to its client. It is spawned under node manager on the instruction by resource manager. It is spawned one for every job and terminates after completion. You can think it like an officer resource manager hires to execute the job and fires it after it has done its duties. Fifth entity is YARN child. This manages the run of the map and reduce tasks and is responsible to send updates and progress to application master. Last entity is the distributed file system, which contains all the necessary input and where output files are returned to. So let us see the steps on how a job runs in YARN framework. First few steps are exactly the same as we had discussed in class MapReduce. The job gets submitted to job client and job client requests for a new application ID. After that, it checks if the output directory is already created. If it finds the output directory, it would throw an error and stop there itself. It then verifies the input directory, then after that it copies the resources to HDFS with a very high replication. And then it finally submits the application to resource manager. Then comes the job initialization phase. So as we have discussed earlier, the resource manager has two parts. First is the scheduler, which will just do the scheduling and allocate the resources. And the other one is the application manager, which monitors the status and progresses of the jobs. So as soon as the job scheduler picks up a job, it contacts a node manager to start a new container and launch a new application master for the job. Application master creates an object for bookkeeping purposes and task management purposes. It retrieves the splits from HDFS and creates one task per split. Next, application master decides how to run MapReduce tasks. If the job is small, the application master decides to run it on the same JVM itself. Since the overhead of allocating a new container and running them on it would cost a lot more than running it on one node itself. These kinds of jobs which application master decides to run on a single JVM are known as Uber tasks. Then comes the assigning phase. If the task is not Uber, it requests the resource manager to allocate the resources needed. Scheduler at this time knows where the splits are located. It gathers this information from the heartbeats of the node managers and thus uses this information to consider data locality while allocating the resources. It tries as far as possible to allocate the node so that the data locality is present, but if that cannot be the case, it considers the rack local nodes. If it fails to even find such a node which is rack local, it allocates any node randomly from the available nodes. Next is task execution. Application master contacts the node manager to launch a container. Then the yarn child is launched. Yarn child is nothing but a Java program named yarn child with a main class as yarn child. Yarn child runs on a separate JVM to isolate the long-running system daemons from the user code. This step is taken in classic MapReduce as well to separate the task tracker from the user code. But one difference is that in classic MapReduce, reuse of JVM of task tracker was possible, but in Yarn, the usage of the same JVM as yarn child is not supported. As a next step, yarn child retrieves all the job resources from HDFS and localizes them and runs the MapReduce tasks. For the next phase, let us just clean up the diagram and drop all the arrows. So the next phase is the progress and update phase. Here yarn child sends the application master the progress reports every 3 seconds and application master aggregates the progress and updates the client directly. In the job completion phase, application master and the task container clean up the intermediate data and terminates itself on job completion. Let us just have a quick recap of the steps followed. The program triggers the job client and the job client contacts the resource manager for the new job ID. Then the job client copies the job resources to the HDFS with high replication and then submits the job. These are the same as we looked in classic MapReduce. Then the resource manager picks up the job from the job queue and contacts the node manager and spawns a new container and launches application master for the job. Application master creates a new object. It retrieves the input splits from HDFS and then creates one task per input split. Application master then decides if the job is Uber or not. If it is Uber job, it runs on its own JVM on a single node. If it is not a Uber job, then it contacts resource manager to allocate computing resources. Resource manager considers data locality while assigning the resources. Application master then communicates the node managers, which launches the yarn child. Yarn child retrieves the code and other resources from HDFS and then run the tasks. Yarn child sends the progress to application master, which aggregates the report and sends the report to the client. On job completion, yarn child and application master terminate themselves and release the computing resources for the next job. This covers the execution of a job in Yarn. In the next lesson, we would look at the failure scenarios.